We will be inviting Sultan Anjum up here. He is a senior engineer at Atlas. He is a passionate tennis player looking for some challengers. So anybody, any takers. So without further ado, sir, step on it.
Good morning, everyone. It's TGIF, so. And I think only one presentation left after this, so hopefully we're done with FRC. All right, I'm Sultan Anjum. I'm with Atlas. I've been in the industry for almost 25 years. This is my third presentation at the FRC. And hopefully looking forward for more, but. All right, this is for a site. It's a site in a bulk oil facility in DeLand. And we try to clean up the Vadose soil and groundwater. This site has issues with soil and groundwater. We try to use NRX with the proprietary stuff, try to clean up the site. It's a DEP program site. It's in PLUR program. It's one of the Springshed site. The history of this site, the facility, as I told you, it's operated as a bulk petroleum facility since '87. And it still provides on and off road diesel, the fuel for the heating oil, the non-ethanol gas, and the boat fueling services. This site has 4 10,000-gallon USTs were abandoned in place, and has 5 ASTs. Supply, storing diesel, unleaded gas, and kerosene. There was a discharge was filed for this site in 1992 because one of the compliance well had product in it. And based on that, the site qualifies for the DEP PLUR program. And you know the PLUR has a limitation, I think it's $1.2 million for the cleanup. The assessments were completed at the site in 1993, and 60 tons of soil was excavated from the top of the USTs during the tank closure. The lithology of the site, it's sandy soil to 8 foot, then you have clay fine sand to 12 feet, and then clay silty sands to 29, and then clay with shell fragments all the way to 45 feet below ground surface. Groundwater flow direction is to the north. Here's a map for the bulk oil storage facility. Let me get the pointer. I think it's not going. It's on. It's not working. I guess the battery's dead. Okay, all right. All right. You can see the 4 USTs that were abandoned in place or closed in place. Then you have the 5 ASTs on site. Let's move to the next slide. The aquifer thickness at this site is 23 feet. The groundwater fluctuates between 4.5 to 8 foot below ground surface or top of casing. The aquifer is a poor aquifer, poor groundwater quality. It's a G2 aquifer here for the site. And as I told you earlier, this site qualifies for a Springshed. There was I think it's 2018, there was a Springshed Protection Act was passed, and that's why the site qualifies for Springshed. For Springshed, in order to be eligible, there's no, the spring needs to be involved, but it doesn't apply for any kind of funding range. So the site could go on cleanup without waiting on the funding score. The contaminants of concern at this site were BTEX, naphthalene, and TPH. And you can see the estimated the Vadose zone soil volume and and the dissolve. Here's the impacted soil map. We have okay. Anyway, we have two areas where we had soil impacts: the SB1 and SB9 and SB8. We had soil exceedances based on the contour of OVA reading 100 parts per million. Here's based on the soil analytical map. You can see the exceedances, especially for toluene, ethylbenzene, and xylenes, and TPH. You can see the exceedances in SB1, SB9, and SB8. We had exceedances. And the soil samples were collected at 4 foot below ground surface, slightly above the water table. Here's impacted groundwater. You see MW1 and MW13D. MW1 is a source well. You see the benzene, toluene, ethylbenzene, total xylenes are smoking high. I mean, the numbers are high. And the deeper one, 13D, has slight exceedances. And you have exceedances in, I think it's MW2. We have considered remediation technology for this site, including natural attenuation monitoring, excavation, using Fenton's reagent. Based on our pre-RAP call, we decided to go with the NREX as a remediation technology because of limitations and the effectiveness of this NREX. The technology we selected was designed to address the adsorb phase and dissolve phase hydrocarbons that are present in soil and groundwater. We couldn't go NAM because nothing has attenuated for 30 years since the discharge happened in 1992. The NREX were selected, and it should come in the next slide on the design, the horizontal, the vertical injection wells. That's layout of the trench and the injection wells. We have 16 injection wells and 4 horizontal wells that we selected, designed to effectively clean up the site. The NRX reagent was injected into the subsurface via 16 vertical injection wells, IW1 through 16. IW1 and 14 were focusing on most of the shallow stuff. Then we have 15 and 16 were in the deeper intervals because we have MW13D had impact in the groundwater. And then we have 4 horizontal wells that were installed to 3 foot below ground surface. And they were constructed of 2 5-foot sections, 10 slot size, and with the PVC Schedule 40 PVC well screen. Here's some of the trench. It shows injection wells and the NRX. Now, what is NRX? NRX, NRX is a hydrogen peroxide. You have SSO, then you have a synergist. The NRX, it's a stabilized and catalyzed hydrogen peroxide that provides highly stable reactions and with safe field applications, no measurable heat, and extended reaction time. The NRX consists of 3 parts: the hydrogen peroxide and the proprietary SSO and the synergist. The proprietary stuff and the synergist is like a stabilizer, oxygen booster, and it's strong enough to oxidize. Isopropyl benzene. Lately, we have seen isopropyl benzene in some of the groundwater And then you have MTB and pesticides. So. And one of the biggest advantage I felt for NRX is it's safe, considering you have storage tanks nearby, tank walls or infrastructure. And it's, so NRX is pretty much used for both saturated and Vadose soil. As it shows in the bottom, it's an all-in-one reagent that can help desorb the mass, provide stable reactions for maximum benefits. Here's one more slide for the NRX reagent overview. Why Focus is automated? We went with this technology. It was approved by the DEP in 2015, but NRX was approved by the DEP in 2005. But the Focus application was approved in 2015. As you can see in the slide, the MW1 concentration on the y-axis, it's in micrograms per liter. In the source well, it went down. When we started, it was like 500, around 500. Then it came back. The goals were reached in August 2022 of this year. The injection overview on the Focus, the NRX feedback, which is optimized control continuous injection system. It injects an oxidant load at low pressure over time and uses water to mix with stored activated chemical and then injects at a slow rate, which was half a gallon a minute. The beauty of this is the injection occurs one injection well at a time, and it cycles through the vertical and horizontal injection wells for a duration as we determine based on our based on our daylighting, how much it can take and all that. It's a solar power system, and it's operate 24 hours a day, and we have cameras to see if there was any daylighting so we can adjust it. So it came out handy for the site. The Focus, we have a 18 valve manifold, we have 18 solenoids. And some of the wells we tied together, a couple of the wells like IW3 injection well 10 and 5 and 15. And as I told you earlier, the Focus allows for easy remote or on-site system adjustments to change the approach, adjust the application, adjust the injection volume. So it helps for engineers. Instead of fighting the site, the engineer can finesse the injection basically. Didn't have to go to the site too often. Here's some of the site injection platform overview. The NRX Focus injection was, we started in August, since August 2019. The wrap was designed for 4,000 gallons of NRX per month of operation through the Focus platform. And we used to go do the bi-weekly O&M activities, which include filling the hydrogen peroxide tanks, the Synergist tanks, and performing the SSO injections and making sure, measure the water quality to see if you're getting the results. And then prior to any groundwater sampling activities, we have to shut the system, then so we can collect the groundwater samples to see how effective. After we did, as part of the first quarter POM, we did the injection for like 1 year, and we collected the POM soil samples. All the soil samples that were SB1, 8, and 9, they were exceedances. They were below CTLs. So the soil objectives were achieved, but we had groundwater issues. So we recommended 6 more months of injection. So we can see in September, we collected those 3 soil samples. And the soil were brought to 0, and the soil samples were below CTLs. Atlas recommended 6 months of focus to reduce the dissolve phase in 1 and 2R. And we achieved the goal, and the site is moving into the PARM phase as of now. So Atlas recommended transitioning to PARM for the site. Here are some of the groundwater analytical data. You can see from MW1, it has went down. You can see the data that was collected in August 2022. And same thing with the MW2. We had some exceedances, but I think it's heading there. And the pHs, you can see it's below CTLs for all the parameters for those source area wells. All right, summary and conclusions. As you can see, we have 2 separate O&M events for the site, 12 and 6 months. We injected 4,000 gallons almost every month for a total of 72,000 gallons of NRX to remediate both the adsorb phase and the dissolve phase. Based on the data, the remedial action implemented the site to reduce both the Vadose and the groundwater COCs to below GCTLs. You can see the groundwater contaminant concentration before it was implemented was benzene was 3,000, toluene was 9,700, ethyl benzene 3,000. They were all below the GCTLs. And one of the advantage of focus, we can modify if we need to adjust the volume based on the quarterly groundwater data. In my professional opinion, the combination of the stabilized, the catalyzed hydrogen peroxide, NRX reagent, and the focus has successfully remediated the problem at the site. And the site is already into the PARM phase. I think I did good, so I was hoping not too many questions, but I'll be happy to answer.
We have plenty of time.
Yeah, no, plenty of time. I see 7 minutes, so.
And again, if you guys wouldn't mind, if you want to step up to the mic or someone, I can hand it to you.
I will try to answer as good as possible. If not, please send me an email to me if I couldn't answer.
Did you have any UIC byproducts from your injection that you had to sample
the
for?
UIC, we monitor for sodium, chloride, and iron, the ZOD monitoring.
Did you see any spikes?
What is it?
Did you see any spikes in those?
Yes, we did, but we haven't reached the background levels yet. That's a good question, very good question.
Thank you.
Yeah, we have six more minutes.
6 minutes, 45
I'll go ahead and ask myself, if you don't mind. So, you used horizontal and vertical wells.
Right.
What was the decision-making process for that? And to add to that, with the horizontal wells, what kind of radius of influence did you see laterally and vertically?
That's an excellent question. Yeah, radius of influence was 12 feet. So, and the reason why we had to go horizontal because of the site accessibility issues on that. Because we have abandoned USTs and we have ASTs, so the spacing was, we couldn't install the wells inside, as you can see in the map. So it's excellent question.
Were your horizontal wells vertebrae wells, or were?
No, it's not vertebrae well, so it's a 5-foot section.
Hey, Sultan, your 72,000 gallons, was that just the reagent, or is that the diluted mixture that you injected? And what size batches did you need to make, and how often did you have to go out and prepare a batch for the injection system?
For the NRX?
Yeah.
Yeah. I have NRX. Who is this here? Anybody here from NRX? I think they can answer.
Back there.
Yeah. Eric can answer better on that.
Yeah. Is this working?
Yeah.
The batches it's more of a continuous batch because it pulls in water. It uses pumped water or supplied water to mix with the activated high strength chemicals. So there's not really batches, so to speak. So the 72,000 gallons is the total injected product, and that's the diluted product. What was the second part of that question? Oh, how often? So bi-weekly visits at the beginning. I think it might have turned into monthly visits once it really got going, and that might be more a question for Sultan.
What is that? Couldn't hear.
Yeah, talking about the frequency.
The frequency?
Yeah, he'd mentioned it.
A frequency of what?
Frequency of O&M visits? Was it just monthly once after the first quarter, I believe?
The sampling was done after, quarter, 7 days after the third quarter, the groundwater sample.
Right, okay. And then, yeah, just the high-strength chemicals, Eric, the high-strength chemicals were reloaded 4,000 pounds per month, so that's every other week.
So Lance, while I got you there, and both of you, I noticed on the curve there was, desorption, right? Yeah. And maybe back diffusion, I don't know, but I mean, do you guys feel like that's over? There won't be any sort of rebound at this point? Enough of the mass has been addressed, or?
Right, so we watch those peaks. They're gonna occur pretty much at every site, especially these clayier sites, right? So you watch those, you see how much they come down, and try to predict that a little bit. Mm-hmm. Obviously, we don't have a crystal ball, but we feel pretty good about it at this point.
Thank you. So I have a couple minutes, keeping this guy on the hot seat here.
Yeah, grill us.
Okay, well, if there's no more questions, we'll go ahead and keep moving. Thank you, Sultan. All right, finally.